So welcome to the third talk or the first lecture series organized by IISER. This is an initiative to bring the cutting edge science to the technocrats, and that's the reason it is being held in Hinjewadi. The larger objective of this initiative is to promote science and industry collaboration to quicken the pace of innovation, new product development, better utilization of available resources within the country, improving yield, productivity in areas like agriculture, etc. Such science industry collaboration will certainly make scientists more aware of the problems faced by the industry and the kind of focus they need to give to the research. And it also helps the industry to know what are the tools available and the kind of intellectual resources available with the scientific community to tap and to make use of it for retaining or enhancing their competitive edge. Increasingly, you find companies collaborating in the field of automotive, technology, engineering, primarily for better utilization of assets, opening up of new markets, as well as exploiting of mining resources. Now, since similarly there is need for collaboration in R&D work, also between industry and science, and but that's not happening much in India. And my own feeling is that possibly that's the reason being lack of understanding of the need as well as the strength between the industry and the science community. So this kind of a lecture series is a very early part of bridging the gap between science and industry. The today's talk is on powering the new world, emergent energy solution for a better tomorrow. Now we are well aware, that most India and most of the countries are now towards renewable source of energy and away from fossil fuel. And we are fortunate to have enough potential on both solar and wind. But the critical area for better utilization of this is going to be energy storage systems, And if you look at the energy storage system, the main consumption, main demand is primarily in the automotive, because 70% of the energy storage system demand comes from the automotive field. And within automotive, as you know, it's a phenomenal change that is happening, because the automotive industry, like in India, we have a target to go for 100% electric by 2030. That's too ambitious. Even if we achieve 50% of that, let's say, by 2030, that itself will mean a huge demand for electric vehicles, which would mean a large demand for obviously batteries. And within battery, I can tell you that the challenge is going to be what the kind of battery that you're going to have to make this whole project viable is going to be energy density, energy efficiency, and the price. You see, the price at which that we are having a lithium battery now, it's not going to be very sustainable. Now what's in India, we are having people import the manufactured cells of lithium and then do assembly here and supplying to the automotive manufacturers. We don't have anyone here manufacturing cells, by which the import of manufacturing the lithium cells into the country itself is going to be a huge forex outflow. And now on one hand, we are able to be taking the comfort that we are going to be saving on oil, but on the other hand, not the same amount, but a good proportion of the money is going towards import of the lithium cells. But if you look at the amount of work that is happening worldwide related to battery development is phenomenal. On all areas of lithium cell battery, research is going on, and we don't know when this is going to become a stable product, because that much of research is happening in all. And if you look at the number of research publication and the patents issued, primarily it is coming from China, Japan, and USA. Even in India now, there are 3 manufacturing facilities that are planned for manufacturing of battery cells, but those are going to be 2 from China and 1 from Japan. And so the bottom line is, we don't have a know-how within the country in India. We are going to be dependent on foreign know-how for manufacturing these cells. So this is an excellent case, very easily justifiable, why industry and science need to collaborate so that we could have our own manufacturing cells, that is the lithium cells, or any other battery cells that science and technology could dictate, which is viable. So now coming to Dr. Ogale's talk today, Dr. Satishchandra Ogale will present interesting possibilities based on the research done by his group in the areas of hybrid perovskite-based solar cells and LEDs, electrochemical water splitting of hydrogen generation, CO2 reduction, and the energy storage materials and devices such as supercapacitors, pseudocapacitors, lithium sodium ion batteries. He will discuss briefly how this energy storage system can drive our need for smart and clean transportation. Dr. Ogale is a professor of Emeritus, Department of Physics, Center for Energy Science at IISER, Pune. Prior to that, he was Chief Scientist, CSIR, NCL. Earlier to that, he was Senior Research Scientist at University of Maryland, USA. He had also worked as a coordinator of Center for Advanced Studies in Materials Science, Solid State Physics, University of Pune. Dr. Ogale obtained his PhD from University of Pune in the field of ion implantation. I should also mention here that he has been a Maharashtra board topper for SSC and Pune topper in MSc and winner of Young Scientist Medal of the Indian National Science Academy. His areas of research include nanotechnology and advanced functional materials, solar energy and optoelectronics, spintronics, thin films and hetero interfaces, self-assembly and pattern information. He has over 480 research publications in international referred journals and has been granted 8 US patents. He has won numerous awards in his illustrious research career. Dr. Ogale.